In this presentation, we're going to look at the normal approximation of the binomial distribution. So we have a straightforward binomial distribution question here. It is known that 24% of the customers in a bank holding a current account also have some other type of account with the bank. That's essentially our definition of a success and the probability of that success. Calculate an approximate value for the probability. Okay, so that gives us a hint that should use some sort of approximation there. That fewer than 50, okay, fewer than 50, x, where x is the number of people holding another type of account, is less than 50. Okay, fewer than 50, x less than 50. Fewer than 50 customers in a random sample of 250 cases. So that's our sample size, or number of independent trials, n, or sample size to use the common vernacular. And in this case, it's a large sample. That's just worth remarking upon. Customers with a current account also have another type of account. Okay, so essentially that's it. So let n be the number of who have another type of account. So n is our variable name here, and n is a binomial random variable with n equals 250 and p equals 0.24. So n is 250 and p equals 0.24. Now in this case, I'm actually going to mix things up a bit. I'm going to call our variable there name n. So essentially, further to the central limit theorem, the binomial variable n can be approximated using the normal distribution. So essentially, just some sort of sentence like this, okay, that's probably not the best that you could do here, but just for the sake of time, just to make some sort of reference to like what justifies this, okay, central limit theorem, large sample size, okay. So that's just really a bit of back and forth reading your lecture notes and checking with your lecture, but just have that there, okay. Just don't forget to include that part, don't skip over it, okay. Like, you have to sort of justify your approach as well as demonstrate that you know what the approach is, okay? So that's grand. So just to sort of fill in a few details that we'll need. So we'll need the mean and the variance here, okay? So essentially what we need to know here is the expected value of n, which is n times p, and the variance of n, which is n times p times 1 minus p. So don't forget those. You might not be given those in the question. Those might be given those formulae, so don't forget that you might need to know them, and you might need to know them off the top of your head and not be given them in a formula. So you should work that out to be a mean of 60 and a variance of 45.6. So n can be approximated using a normal distribution, with n approximated by normal 60, mu equals 60, and sigma squared equals 45.6. Now just this once, I call it norm, just to sort of be distinctive from n, which is the variable name. Okay, so n is the normal distribution. That might be overkill, but like, you know, just to be as clear as possible that n and is the variable name and norm is the distribution name here. Okay. Now, so something that we're going to use here is continuity correction factors. Now, these pop up a lot, okay? You might not be required, you probably will be required to use them if you're doing questions like this, but sometimes, you know, your lecturer might let you off with it. So essentially, what we were asked for in this question here is fewer than 50, okay? N is less than 50, okay? So essentially n is less than 50. So when we transform that with a continuity correction, we just take off n minus 0.5, okay? So this is the correct case here. So essentially what happens is it becomes 49.5 with a continuity correction, okay? And after that, it's a straightforward normal distribution calculation. Get the z-score, and that should be equal to minus 1.55, probably z minus 1.55, and What is this here? But essentially, I'll just leave that go, but it's not really worth it. But you should get an answer of minus 1.5 minus 1.55. So you should get an answer close to 0.061. That rings true, so that is pretty sure that's the right answer. But I think I just added in some details there that I really shouldn't have. Okay, we'll leave it there.